So in this lecture I will discuss about balanced slope detector or round traverse detector. Okay, so this is balanced slope detector. So in slope detector the slope is not linear. We know that in the previous lecture I discussed about the slope detector, and then the problem with the slope detector is the slope is not linear, so there occurs a 1 volt error. I have shown that 1 volt error now. So that is due to the slope error. We call this a slope overload error. This kind of slope error can be eliminated with the help of this balanced slope detector. So slope detector slope is not linear, so output message will not be exactly same as that of message. So to overcome this, we use balanced slope detector. This increases the linear region of operation. Okay, the stage it is having a staggered tuned circuit. Staggered tuned circuit means tuned circuit which is having both different tuned frequency. Look at the circuit. Here the primary is connected to the FM signal, secondary is tapped, secondary is center tapped, and it is taken taken as a two tank circuit. Okay, here this inductor and a capacitor form one tuned circuit. This inductor and another capacitor CT2 form another tuned circuit. So CT1 and CT2. So these are the two different tuned circuit, and both it is secondary is a center tapped transformer. So this is tuned circuit to 1 T1, this is tuned circuit to F01 is the center frequency of this tuned circuit, and F02 is the center frequency of this tuned circuit. Okay, and the rest of all is same only, see look at the upper part and lower part, both are symmetrical to each other. Okay, so this is look like the single portion, the single upper part, it is look like a slope detector rotor. So like that two slope detectors are connected in, we can say that means two tuned circuits or two circuits which are symmetrical and are connected. So the remaining portion after the tuned circuit, the remaining portion are nothing but our envelope detector only. Okay, so the thing is it is balanced means both the upper part and lower part are balanced, symmetrical rotate. That's why we got the name balanced. Here why? Because the diode D1 and D2 are identical, C1 C2 identical, R1 R2 both are identical. Okay, so look at the output voltage. So here it is upper when this diode conducts, this resistance have a voltage V1. When the lower diode conducts, this resistance have a voltage V2. And look at the polarity also. From this polarity we can find out that V out equal to V1 minus V2. Now how this balanced operation happens, or how the error can be eliminated, as in the case of slope detector there creates some error, all those things that can be eliminated with the help of this circuit. How? The thing is, when you apply the primary frequency modulated signal, you apply it to the primary. Secondary, it will be induced into the secondary. Secondary is tuned to a particular frequency. Both the tuned circuit are at a different frequency, and this is 180 degree out of phase compared to this. Okay, this and this are 180 degree out of phase with each other. Okay, so this is the characteristics of that tuned circuit to 1. This is for tuned circuit to 1 characteristics, this blue light, and this is for tuned circuit to 2 characteristics, and this green line indicates the combined effect of or the equivalent tuned circuit characteristics of this entire circuit. This one represents the upper tuned circuit characteristics, and this one represents the lower tuned circuit characteristics, and this green line represents the resultant tuned circuit characteristics. Okay, and how it is working, look at here. When you give a supply, when you give an FM signal, you get an induced voltage, and these two are tuned to two different frequency. Okay, these two are tuned to two different frequency. Look at here, at a resonant frequency, at FC, suppose this is my carrier frequency, this is F01, this is F02. F01 is greater than FC. F01 means this tuned circuit frequency is greater than the carrier frequency, and F02 is less than FC. That means this tuned circuit frequency is less than the carrier frequency. That's why f01 is on the right side, f02 is on the left side. See, at carrier frequency fc, when the incoming signal is at carrier frequency fc, what will happen? Look at here. This upper tuned circuit provide a voltage. This is actually voltage versus frequency graph. The upper tuned circuit provide this much voltage, from here to here this much voltage. At the same time, lower tuned circuit provide this much voltage, here to here. Both this and this are same, but both here to here same voltage, here to here same voltage. One is positive, one is negative. Both are cancel out each other and output is 0. Okay, this is the case when f equal to incoming signal frequency is at fc. When f in equal to fc, that is the case. Okay. Now when the carrier frequency is greater than fc, f0. See, look at here, carrier frequency f0 is greater than f01. This is actually f01. f01 is greater than fc. That means tuned circuit to 1 frequency is greater than the carrier frequency. Look at here. Here tuned circuit frequency is greater than carrier frequency, so the gain is increasing, or the output voltage is increasing. What happens in less than f02 is less than fc? There the gain is decreasing. In negative side it is increasing, that means it is decreasing. Okay, so this is the carrier representation. Now we need to know how this demodeling process done. Okay, anyhow we need to, in output we need to get a original message. No, this is FM signal, we need to reconstruct original message. That is our aim. So consider the three cases. Consider these three cases. One is f in equal to fc. When f is equal to fc, that means this is the graph. When incoming frequency, this is f in. When f in equal to fc, when f in reaches fc, what will happen? The tuned circuit to 1 provide a voltage Vt1. Vt1 equal to Vt2 means when Fn equal to Fc, this tuned circuit 1 provides a voltage Vt. This tuned circuit provide another voltage Vt2. So Vt1, Vt2 both are equal, that is V1 equal to Vt2 both are equal. So those will cancel out each other. V out equal to 0, that is V1 equal to V2. Here it produces a voltage V1, this also produces a voltage V2, both are equal. How they are equal? Why? See, at the resonant frequency, this is the gain, or this is the voltage from here to here. Here also here to here. Both these voltages are same at this y-axis. And one is negative, one is positive. So the resultant is 0 only now. That's why one is positive, one is negative. So V1 is positive, V2 is negative. V1 equal to V, V2 equal to, both are equal, so this will be 0. V out is 0. Now, second case, Fn is greater than Fc, less than F01. Look at here, Fn is greater than Fc means this region, less than F01. That means here. So greater than Fc, incoming frequency എന്ന് പറയുന്നത് greater than Fc ആണ്, less than F01 ആണെന്ന് വിചാരിക്കുക. അങ്ങനെയാണെങ്കിൽ എന്തായിരിക്കും ഗെയിൻ? ഈ സമയത്ത് ഇതിങ്ങനെ മുകളിലോട്ട് കയറിക്കൊണ്ടിരിക്കുകയല്ലേ. സോ ഈ ഗെയിൻ പോസിറ്റീവ്, V1 കൂടുതലും V2 കുറവായിട്ടും വരും അല്ലേ. V1 എന്ന് പറഞ്ഞാൽ എന്താ? ഫസ്റ്റ് ട്യൂൺഡ് സർക്യൂട്ട്. V1 എന്ന് പറഞ്ഞാൽ ഈ ഫസ്റ്റ് ട്യൂൺഡ് സർക്യൂട്ട്, അവിടെ കൂടുതലും ഇവിടെ കുറവും വരും അല്ലേ. അതാണ് ഇവിടെ എഴുതിയിരിക്കുന്നത്. Vt1 ഗ്രേറ്റർ ദാൻ Vt2, അതായത് അപ്പർ ട്യൂൺഡ് സർക്യൂട്ടിൻ്റെ വോൾട്ടേജ് കൂടുതലാണ്, അതാണ് V1 ഗ്രേറ്റർ ദാൻ V2. അറ്റ് ദാറ്റ് ടൈം റിസൾട്ടൻ്റ് വോൾട്ടേജ് പോസിറ്റീവ് ആയിരിക്കും അല്ലേ. V1 is greater than V2. V1 is greater than V2, so V out is positive only. So we got a positive voltage. Okay, now less than, Fn is greater than Fc2, less than Fc എന്ന് പറഞ്ഞാൽ ഇവിടെ എഫ് സിയെക്കാട്ടി കുറവും F0യെക്കാട്ടി കൂടുതലും. അപ്പോൾ ഈ ഒരു റീജിയൻ നോക്കും, ഇവിടെ എന്താണ്? വോൾട്ടേജ് നെഗറ്റീവ് ആണ്. ഏതാണ് നെഗറ്റീവ്? V2 കൂടുതലും, V1 കുറവുമാണ്. V1 0യിലേക്ക് വന്നുകൊണ്ടിരിക്കുകയാണ്. സോ V2 is negative and it is high. So V1 is almost 0, V2 is negative, so the resultant is negative. Okay, that's why it is written Vt2 greater than Vt1. In this condition, V2 is greater than V1, so V out is negative. So V out is negative. So what will happen? At the resonant frequency, no voltage. At Fc, no voltage. As the frequency increases, we got a positive voltage. As the frequency decreases, we got a negative voltage. That means what? This is actually the frequency. This is the FM. Here high frequency, here low frequency. That means at a high frequency we got a high voltage. That means for high frequency I got a high voltage. Low frequency, that means this region I have a low negative voltage. That means I have a negative voltage. See, original message I reconstructed. Okay, now this is the modulated signal. This is I reconstructed with the help of this. So after analog detector, this is the result. So നിങ്ങൾക്ക് അങ്ങനെ ഡീമോഡുലേറ്റ് ചെയ്തിട്ട് ട്യൂൺഡ് സർക്യൂട്ട് വഴി അതിനെ അനലോഗ് ഡിറ്റക്ടറിലൂടെ പാസ് ചെയ്ത് കഴിഞ്ഞാൽ ഫൈനലി യു വിൽ ഗെറ്റ് ദി ഒറിജിനൽ മെസ്സേജ്. സോ ദിസ് ഈസ് അബൌട്ട് സ്ലോപ്പ് ഡിറ്റക്ടർ. Advantage of slope detector: more efficient and it is more linear than simple slope detector. Disadvantage: difficult to tune different circuit at a different frequency. Amplitude limiting is not provided. Okay, that's about balanced slope detector. Next is PLL, that will discuss in next class.